Okay, I think we can start. Hello, everyone. Thank you for attending this webinar. My name is Rafik Lamri. I'm the director for Middle East and North Africa region at IntelexVision. Today, I'm going to present the vision of IntelexVision and what we can do with artificial intelligence using our software platform called iSentry. So our vision is to effectively and efficiently monitor video in real time. So you know that the majority of the control room nowadays rely on playback, on video that has been recorded. So there is no information, there is no intelligence coming to the control room, except if a security guard or someone alerted or see something and then inform the control room. So all the camera are effectively only recording without sending any information back to the control room. We want to use artificial intelligence in order to make those cameras understand what they are watching. And then if there is an abnormal activity, then it will send an alert. So the artificial intelligence will be smart enough to understand what is normal, what is not normal after a certain period of learning and send an alert. So this is the main objective and vision of IntelexVision. Please, if you have a question, there is a Q&A where you can write the question. You can raise your hand as well, and we'll do our best to answer the questions. And I forgot to mention that this webinar is with the collaboration of Dix4Tech, our partner in Qatar. So, transforming control room operation. We had the traditional video analytics for more than 10 years now, which is basically predefined algorithm. So mainly tripwire, like a virtual line, and then if someone go through, there is an alert, the people counting, fire, etc. So the challenge with this is, first, for each field of view, you need to think about what could happen. You need to know what algorithm you're gonna use, etc. So sometimes you don't know what happened, what's going to happen. Sometimes you know what's happening, but you don't have the exact algorithm to make the alert. And third point is very difficult to scale when it comes to more than 50 camera. It's become a nightmare to scale. So our innovative approach is to use a self-learning based network with the powerful pixel-based deep learning. So we'll talk about it. So the system, after a certain period of time, will self-learn the scene, all the field of view from all the camera. Then we'll start generating alarm by itself. So the result is around 30-fold improvement in detection rate. And so 30-fold improvement in detection rate compared to the traditional video analytics. That means that it is not twice or 3 times, it's 30 times more information coming from your video surveillance. Of course, there will be some filtering because not all the information are important for certain verticals. So we will be able to use filters to receive only what we need. And then up to 15-fold increase in a number of camera an operator can effectively manage. So this means that we'll give you an example. In Johannesburg, we have a city surveillance project with around 12,000 camera. And there, the ratio is around 400 camera per operator. Here in the Gulf region and Middle East in general, it's much more safe. So the ratio is around from 900 to 1,200 camera per operators. So one operator will be able to manage up to 1,000 camera in using the artificial intelligence alerts. So now let's talk about the evolution of the video analytics and how we could achieve this video, this AI and self-learning and etc. So we need to understand, because there is so many video analytics in the market, we need to understand the basic and the evolutions of those video analytics and how to compare between an engine and another. So as you can see here, there is 4 distinct generation. They're all in use. We all need them. Okay, there is nothing obsolete here. They all evolved within their respective time. So you can all remember the video motion detection, first generation, tier 1, is basically any pixels that move, we take an action. Then they included the concept of sensitivity to avoid false alert, like shadow and trees moving, etc. Then around 2000, the analytics, which is like fixed algorithm, start like tripwire, for example. So if there is a virtual line, and then if a group of pixels cross that virtual line, we take an action, and then people counting is the same. So before it was not, we call them people counting, but it was mainly a group of pixel counting. That's why they were required to have a camera 90 degrees looking at top. Now, with the use of third generation deep learning, we can understand the machine. The first use of artificial intelligence can understand what the video is sending. So we can understand that this is a person, this is a vehicle, this is a bottle of water, this is a laptop, etc., etc. So here, for example, we can see a video using people counting using the latest generation of iSentry of deep learning. So you can see here that even at a very long range and difficult angle, but the system is capable of classifying hundreds and maybe more than maybe thousands of people in one scene. So this is how the evolution went from just counting a group of pixels to counting persons using very difficult angle and long distance. Okay, let's go back to the second generation. They added the concept of time. So if this group of pixels does not move for more than 5 minutes, then it's a left object, and vice versa for a missing object. Now we don't talk about object, we talk about specific objects. So we can say if a person, or if a wallet, or if a backpack is left, then give me a certain kind of alert. Then we have tier 3, which is a combination of the second generation with the third generation deep learning. So because we know what we are counting and we know what we are seeing, we can create much more features. So for example, now there is object counting. We don't count only person, we count many objects. So we can count different animals, we can count buses, vehicles, bicycles, etc., etc. So how many chairs are here, how many wallets are in the table, etc. So this is the advanced object counting, and then area counting, and then we have heat map. So a lot of information are structured in order to display and help people. So using multiple user interface like heat map. Crowd management. So because we can now count persons in a very crowd environment at a very long range, we use density to know if there is a risk of a stampede or suffocation, etc., etc. We do have PTZ tracking. We do analytics on PTZ, like detection, face detection, protective personal protective equipment at a very long distance. So we do have like 40 or 50 features. So I cannot go through all of them. But the concept is using second generation rule based. So a rule engine based on Boolean, so if, and, or, not, and then you combine this and this, and then you can create the features. So this is how it works. Now let's jump back to the third generation deep learning. So we use a very advanced deep learning called pixel-based deep learning. That means that the system is able to classify object even if their silhouette is not complete. So even if, for example, I'm hiding half of my body is hidden under a desk, the system still will be able to classify me as a person. So, and even if the angle is not correct, for example, the camera angle is not 45 degrees, is 60 or 90 or whatever, we will still be capable, the system is capable of classifying. So the tolerance in terms of distance, in terms of angle of view is very high using our advanced deep learning technique. So basically there is tier 1, tier 2. So tier 1 is person, face, vehicle classification. You will find this in many camera as well, but of course they don't have the same deep learning technology. So for example, if there is a bars between the camera and the object, then it will stop classifying because the silhouette, the angles are modified by the bars. So there is a lot of challenge here if we don't use a very advanced deep learning like our pixel-based deep learning. Tier 2 is basically more object, and specifically a static object. So camera does not usually classify static object because they don't want to use their CPU too much. So they make it only on motion. So basically persons and vehicles. So we classify almost everything, including static object like chairs or table or TV, monitor, etc. We'll talk about later in the fourth generation why we do that. And then we have the latest tier 3 deep learning, which is a deep learning to classify pose classification of humans. So let's see a video. So the system will be able to detect or understand the human skeleton, and therefore extract the pose classification of, so if he's walking or running or sitting or falling down, etc., etc. So this is another technique we use called tier 3 deep learning pose classification. Okay. Please feel free to ask question on the chat, or on the Q&A. Okay, so after the deep learning, we have the self-learning. So this is the fourth generation. This is the latest generation, where the system is able to understand by learning the scene, understand what is normal and what is not normal. So let's see an example here. So for example, this is a video taking from street surveillance. So it shows the system detecting an unusual behavior of a person after learning the scene for 3-4 days. He found that this is very suspicious because of the way he was walking, and the system was right. You can see here that the system detected many alerts in one event. You can see when he stole the phone. And sorry, let's make it like this. Up, yeah. And you can see here 2 other alerts. So when before he stole the phone, after he stole the phone, when he's running in the middle of the road, that's all not normal. And then you can see here another alert, unusual behavior alert coming from the car. That's because the car went out of the parking and the door open. So the system never seen a vehicle moving while the door is open. So this is how basically the system alert on what is normal and what is not normal after learning the scene. Okay, we have a question. I mentioned filter. It is used to reduce the false alarm per scene, type airport malls, etc. How many filters types or category you have? Okay, excellent question. So this question, I'm going to answer it with tier 2. So this one, tier 2, is where we apply the filter. So imagine you have a scene where 2 cats are fighting in a parking lot. The first generation, tier 1, will send an alert to the operator. Operator will not be interested into cat fighting in an outdoor camera. So what we can do, we'll use tier 2. So tier 2, instead of sending the alert to the operator, we'll send it first to the deep learning engine. The deep learning engine will classify the object in the scene. This is why I told you we classify almost everything, including static object. So those cats will be classified, and the self-learning, the unusual behavior, will tag them as the one creating this event. The deep learning will, before sending anything, he will check if there is a rules set by the second generation. So in the rule-based, I will create a rule saying if there is any unusual behavior of animals, or I can select which animal, cat, dog, giraffe, zebra, etc., or I can just select animals in general. In my outdoor group of camera, dismiss. So this is how I created the filter to avoid, they're not false alert, they're alert, they're legitimate alert, but but they're not important. They're not important for certain verticals. So this is how we create a filter. So let's see here a demonstration. Here it's the opposite. Here, instead of dismissing, I am putting a priority. So this is a shopping mall in Singapore. And so the operator of the mall wanted to have a critical alert when it comes to people wearing, having a suspicious behavior and wearing a helmet. So as you can see here in the video, the system detected this person, classified his cell phone, classified his helmet, and he sent an unusual behavior. Why he sent an unusual behavior? Because the system never seen a helmet before. So he sent an alert, and that alert become critical alert because it is compatible with the rules I created, saying that if there is an unusual behavior of a person wearing a helmet, give me critical alert. So this is another way of filtering, but filtering in the other sense, like give me a critical alert, not a normal alert. So you can dismiss, or we can prioritize, depending on what we want to achieve, using the 3 engine here. So self-learning, deep learning, and then the rule-based. I hope that answered the question. Okay. Okay. So now that we understand how the system work approximately using the filter, etc., and the self-learning, let's go back to the first generation where we have made some improvement as well. So you have the tier 3. So it is like detection of object, but now those objects are well known. So they are persons or vehicles. So you will find this technology in camera as well. The problem with this technology is that if there is any environmental disruption like rain or cloud or anything that is environment, it might disturb the deep learning classification of that specific object, and therefore it will not be detected. Especially when the number of pixels are not enough to classify that particular object for long distance, for example, etc. So in order to fix this issue or this challenge, we have created the tier 4. So tier 4 is using video motion detection with self-learning. So the self-learning here is not 2-3 days, it's just around 3 to 5 seconds. Understanding the environment, understanding how the pixels moves, and then focus only on smart objects. So smart object detection. What is a smart object? It's a person, it's a vehicle, or an animal. So any pixel that move in a smart way will be detected in conjunction with the pixels that move like environment. So let's see some video here. So here is a thermal camera at 320 resolution. The temperature of the soil is almost like a human, around 39, 40 degrees, and it is windy. So it's a very, very challenging environment for any analytics. But you can see that the system already detected the object, which is a person. Of course, when we see it with our eyes, our brain is so sophisticated and advanced that we understand that it is a person. but yeah, the AI as well. So he doesn't understand that it is a person, but he knows that it is a smart object. So he's not taking the tree moving or any other object. He's always tracking the person on the field. So for perimeters, intrusion, etc., this is very, very helpful, and it works also on long range. So that was around 50 or 70 meters. Let's see something at 700, 800 meters. So this is a better camera, a thermal 640 resolution FLIR. And we can see that at around 800 meters, the object has been detected, with few pixels only. And we use a drone to check the object because it's too far away. So you might use a very powerful zoom, or you can use a drone if it is permitted. And this is our engineer anyway. So this is how we use environmental filtering to detect smart objects. Here, just a demonstration of the engine, area monitoring. So the system will focus only on smart object. You can see here a bird that's been detected in the middle of the tree at long distance as well, 500, 1 kilometers, still detecting only objects. You can see the duck in the middle of the water detected. This is a copper mine. This is 2 kilometers out of 4 kilometers wide, and we are still detecting any movement. So imagine if we need to secure this copper mine using traditional camera and analytics, we will need, I don't know, 20, 50 camera with WiMAX, with solar panel, etc. So it will be very expensive to deploy. So using our software, we can have 1 or 2 camera with the wide angle. And if any intruder comes to that place, it will be detected even at a very long range. The only thing is we will need to use a patrol or a drone or anything to check if it is not an animal. Okay, let's continue. So just to explain how the process works. So we have 100% in 24 hours of raw video data, okay, coming from the camera. The first engine will filter those footage using the AI. And approximately it will end up with 2% of worth of data that need to be analyzed. So 98% in average will be eliminated or dismissed by the AI because everything is normal. There's nothing to alert off. It's a normal situation. So let's say an average of 2% is picked up by the first engine. Then the second engine, which is the deep learning with the rule engine. Remember the cat fighting example I explained before. So that will do another filtering, and let's say average will end up with 6 minutes that will be dismissed by the second engine. 1 minute will be sent to alarm. For example, if there is 2 persons fighting, so I classify 2 persons and then I classify that they are fighting, and it is an unusual behavior. Then if all these 3 categories are raised, then it must be critical. So, and it doesn't need to go to the operator, it will go to the supervisor immediately and it will not be an alert, it will be an alarm. So this for, let's say, 1 minute of this type of scenario. And then 3 minutes is the system has detected something unusual, but there is no rules attached to it. So what we call the gray area. So the gray area might come sometimes, and we have a choice. So the operator anyway will deal with it. He will see it. He will have a 5 seconds video with the pictures showing the object causing the alert, and will decide whether to dismiss or to raise the alarm to a specific department, following a standard operating procedure, etc. So everything is available in the UI. After that, we have the option to say if we need to implement a new rules to avoid the stream need, to try to make it 1 minute or less. So if we can create a rules to eliminate that, okay, like this 2 minutes, for example, we want to eliminate them into dismiss using a rule. So we can do that. So next time he will not have to deal with 3 minutes, maybe he will have to deal with 1 minute, etc., etc. So this is how the iSentry process work. Any question? The presentation has ended. If you have any question or you want to see other video or you are interested into any use case in particular, please let us know. Okay. I guess we have a question. Do you have the forklift truck video? Okay, you mentioned raw data in the presentation. Is not the metadata being transferred from the VMS? So there is 2 ways of taking the raw data. We can take it from the VMS, or we can take it from the camera itself. And then the metadata will be generated after the first engine treatment and after the second engine treatment. So the first engine will give you the bounding box of the group of pixels detecting the anomaly, but it will not give you the classification. So the second engine will do the classification, and he will tell you that it is a person or a vehicle or an animal, etc., that is causing the problem. It could be a static object as well, like door open, left open. So the system will detect the door left open, and will send you an alert saying that this is unusual, that this door is left open. So it's not only on smart object, it's on everything. Even on, for example, fire or water leak or electric sparking, or anything that is unusual will be detected by the first engine, and the second engine might or might not classify. For example, water leak will not be classified because we don't do water leak classification as for now, but any other object that can be classified will be classified and will be inserted into the metadata. Forklift video, Chris Brown, I don't have that video. Okay, any other question? All right, I think no more question. I guess I explained well, hopefully. Okay, thank you guys for attending this presentation. And thank you, Dux4Tech, for the initiative. Thank you everyone.